Imagine this, the first alien you ever meet doesn't have eyes, it doesn't have green skin or a flying saucer, or even the need for light. Shocking? Good, because that's closer to reality than anything Hollywood ever sold you. The question is not if there are aliens out there. The question is, what on Earth, or rather, what off Earth, would they even look like? When you picture an alien, maybe you see bug-eyed creatures with shiny heads, or the little green men from old cartoons. Cute, spooky, but wrong. Life, as science shows us, doesn't repeat human imagination. It adapts to environments in ways so extreme, so bizarre, that the truth will probably leave your jaw on the floor. Just look at Earth. Right here, under our noses, life has already written 1,000 alien stories. Blue dragon sea slugs that look like they crawled out of a fantasy painting. Snails that build their shells out of pure iron. And eyes, lemurs so strange that early explorers thought they were demons in disguise. If life on this one small planet can invent such madness, imagine what countless worlds across the universe could create. Here's the twist. Real aliens may not look alien at all. They may look like nothing we've ever dared to imagine. So put on your future science suit, step through the portal with me, and let's dive into 3 possible worlds more alien than anything you've ever seen. But before we cross that line, do one thing, hit subscribe and stay with us, because this isn't just a story about monsters, it's about you, me, and the future of life itself. Now, are you ready? Let's go. Before we rush off into alien worlds, let's ground ourselves at home. Earth, our familiar blue planet, is already bursting with life forms so bizarre they could headline any sci-fi movie. If you want to know what aliens might look like, you don't need to leave the solar system. You just need to look closer at the creatures sharing this planet with you. Consider the blue dragon sea slug, a living piece of abstract art. It drifts upside down on ocean waves, its body patterned with silver and electric blue, looking more like a cosmic nebula than a mollusk. Or the scaly-foot snail, which literally forges a shell out of iron, wearing armour that would make medieval knights jealous. And then there's the eye, a lemur so peculiar with its oversized eyes and long skeletal finger that early explorers in Madagascar thought it was cursed. These are not fantasy sketches, they are facts. Real organisms, real adaptations, thriving right here on Earth. And that's the hook. Life doesn't just find a way, it finds a weird way. Imagine explaining the eye to someone who has never seen a primate. They'd probably laugh it off as a monster from a folktale. Yet here it is, alive, chewing on sugarcane in the forests of Madagascar. If evolution on this single planet can invent iron snails, psychedelic sea dragons, and lemurs that look like goblins, then what could billions of years of evolution on distant, exotic worlds produce? Think of it like Hollywood. Just when you think you've seen every kind of superhero movie, the studios find a new twist, a stranger character, a plotline nobody predicted. The universe works the same way, except it has had almost 14 billion years to perfect its storytelling. So when we are, what do real aliens look like? Maybe the best way to prepare our imagination is to realise we're already living among aliens. They just happen to call themselves Earth life. And if that's the baseline, buckle up, because the first stop on our journey will make Earth's strangest creatures look almost ordinary. Step through the portal, and the first thing you see is darkness. Not the cozy kind of night you know on Earth, but a permanent twilight that stretches across half a planet. Welcome to Iper, an ice-covered world circling the dim red dwarf star, Oculus. Oculus is 5 times smaller than our Sun and far less bright. Yet Iper orbits 20 times closer than Earth does to its star, locked in an eternal dance. One side of the planet faces eternal day, scorched by a weak crimson light. The other side is frozen in perpetual night, colder than Antarctica. But right at the razor-thin line between fire and ice lies something extraordinary. A shallow black ocean known as the Eye of Iper. This ocean is no Caribbean paradise. Its deepest point is barely 200 meters, and a never-ending storm churns its surface as hot winds crash into icy gales. From above, it looks like chaos, but below the storm's fury, calm, stability, a hidden world. You dive in expecting emptiness, but instead you land in a jungle beneath the waves. Vast kelp-like forests stretch upwards, swaying in the murky water. On Earth, seaweed is green because it feeds on red light. But Oculus emits so little light, mostly in the infrared, that plants here have evolved to be jet black. They absorb every scrap of energy, giving the eye of Ipa its ominous dark glow. Every inch of seabed is claimed. Roots grip the mud like fists competing for nutrients. There's no room for newcomers. Only death makes space for new life. And then, movement. Streamlined, teardrop-shaped creatures slip through the forest like schools of underwater cattle. They graze lazily on the black leaves, shaped by evolution into perfect bodies for reducing drag. They look familiar, almost like fish, but here there are no eyes to see them. Because in this lightless ocean, vision is useless. Life doesn't rely on sight, it listens. The water is filled with sound, clicks, hums, squeaks, rattles. A cacophony of voices, as if the forest itself is alive and singing. Predators and prey communicate through textures and vibrations, dueling not with sight but with sound. Suddenly, a patch of leaves begins to writhe. It is no plant. A camouflaged predator unfurls, wrapping its tendrils around an unsuspecting grazer. Jaws snap. The victim is dragged into the shadows. Around you the chorus swells, spike bulbs squeaking, seed eaters clicking as they sift mud, star-shaped grabbers flapping to snatch smaller prey. The noise is chaotic, eerie, almost beautiful. And then you hear something else. A shift in the rhythm. Blind creepers, spindly hunters that crawl silently through the forest, have noticed you. Their movements vibrate through the water, and they are closing in. You came to explore this world, not to become part of its food chain. Time to leave the eye of Ipa behind before the chorus drowns you out forever. You emerge from the dark ocean into blinding light. Above you burns Carulius, a massive blue star, hotter and brighter than anything our sun could dream of. Orbiting close by is Nimbus, a gas giant the size of Neptune. Unlike the cold worlds of our solar system, this one is alive with warmth and water. From orbit, Nimbus looks like a canvas of swirling white, its clouds as large as continents. Titanic updrafts push vapor miles into the sky, forming mountains of mist that drift endlessly. And inside those colossal clouds, life has found a way. Billions of years ago, microscopic extremophiles adapted to the harsh chemistry of Nimbus, breathing methane and breaking down sulfur compounds. As the star grew hotter, life was carried higher, spreading through the cloud layers. Today, Nimbus is home to a vast sky ocean teeming with creatures. The smallest inhabitants are cloud plankton, tiny spider-like beings no bigger than a pinhead. Each has 4 delicate legs tinted yellow from the sulfur they consume. To stay aloft, they release electrostatic threads, thinner than spider silk, riding the electric currents between layers of cloud. On Earth, some crab spiders use this trick to float for hundreds of miles. Here, it is a way of life. And right now, you've arrived at mating season. Billions of cloud plankton weave their threads together into massive parachutes, riding warm updrafts for hundreds of kilometers. At the top of their flight, they hatch their eggs, filling the skies with a snowstorm of life. But where there is abundance, there are predators. Other creatures cling to the parachutes, waiting for fresh hatchlings to devour. And from below, shadows rise, shapes so vast you struggle to comprehend them. The sky whales, towering larger than skyscrapers, yet delicate as balloons. Their bodies are thin membranes inflated with heated gases, making them lighter than the air around them. Hanging beneath each balloon is a car-sized sphere of organs, the control center of the beast. Like blue whales on Earth, sky whales are filter feeders. They unfurl enormous sticky nets that sweep through the clouds, trapping trillions of plankton. Most are consumed immediately, burned in specialized glands that generate heat to keep their bodies buoyant. The excess is transformed into a glowing orange nectar, thick with energy, stored for leaner days. But nectar is the most precious resource on Nimbus. and predators stalk it relentlessly. Jet squids, frog-sized cousins of the sky whales, trail behind like thieves. They cannot float efficiently, so they blast superheated gas from their bodies in short bursts, rocketing through the clouds. With needle-like beaks, they step at the sky whale's nectar sacs, drinking greedily before darting away. It is a delicate balance, titans drifting slowly above, parasites darting below, and a sky ocean filled with plankton, drifting wherever the winds command. Beautiful, fragile. But Nimbus's paradise comes with a ticking clock. Carulius, the blazing blue star, will not live forever. Its lifespan is measured not in billions, but in mere hundreds of millions of years. Already it burns through fuel at an unsustainable rate. When it dies, Nimbus and all its skybound wonders will be obliterated. Life here is barely 600 million years old. In cosmic terms, it may have only 10 million left. Is that tragic or miraculous? That an entire world could exist, thrive, and vanish before we even knew it was there? Maybe both. Your jetpack sputters. It's time to leave before Nimbus becomes your final resting place among the clouds. Your next step takes you into the shadow of Orsted, a brown dwarf 13 times more massive than Jupiter. Its magnetic field is 60 times stronger than anything Earth could produce, a cosmic dynamo crackling with invisible power. And circling close to it is Monnier, a tiny moon that should be barren, frozen and lifeless. Yet impossibly it is not. Gravity here is barely 5% of Earth's. The thin atmosphere is mostly carbon dioxide, too weak to hold heat. Nights plunge into the temperatures so low that dry ice falls like snow, blanketing the ground. Overhead, glowing ribbons of red, green, and blue shimmer across the sky, auroras painted by Orsted's magnetism. But as the nearby yellow star sturgeon peeks out from behind Orsted's bulk, the world awakens, temperatures spike, the ice groans and cracks, and suddenly geysers erupt. From the fractures flow shimmering streams of ammonia mixed with liquid metals, creating surreal rivers of colour across the frozen land. And then life reveals itself. Bundled shapes rise from the fissures, unfolding like origami flowers. They are plants, if you can call them that, rooted in magnetic minerals. Their blossoms are saturated with iron and cobalt, giving them an uncanny shimmer. With gravity so low and magnetism so strong, these sky flowers do not just grow upward, they float, levitating hundreds of meters into the air. Imagine fields of glowing flowers drifting like kites, catching the last rays of the setting star. They extend the sunset by chasing the light, magnetically suspended in the sky. Beautiful, alien and dangerous. Touch one and it snaps free with a violent crack, soaring higher out of reach. But the plants are not alone. Suddenly the ground trembles with motion. Hundreds of creatures, shiny and slick like living snails, race across the icy surface. They extend two long conductive stalks from their heads, which merge above like a kite. These skaters ride Monnier's magnetic currents at breathtaking speeds, gliding across the surface faster than the setting sun itself. On their backs grow colonies of purple microorganisms, photosynthetic symbionts that act like living solar panels. The microbes produce sugars in exchange for endless sunlight, while the skaters keep moving to prevent their partners from freezing. Stop for too long and both would die. It almost seems harmonious, until the ground splits beneath one unfortunate skater. A spiked claw of metal bursts upward, seizing the creature in an instant. The attacker is an ambusher, part beetle, part sea lion, lurking beneath the crystalline crust. It crushes its prey and drenches itself in glittering fluids. For these predators, patience is survival. They lie in wait like landmines, striking when the vibrations of passing skaters betray their presence. The beauty of Monnier hides a brutal truth. Every step could trigger a predator's strike. Every moment is a gamble between light and death. The star sets, and darkness falls again. Temperatures plummet, the auroras grow brighter, and now the fragile window of survival closes. You feel the chill bite through your suit. Time to retreat before Monnier swallows you whole. 3 alien worlds down, and each one is stranger than the last. But let's shift the lens back to us, because if the universe can build predators that hunt with sound, whales that float on gas, and flowers that levitate on magnetism, then what kind of defences might we need one day? Imagine Earth wrapped in armour. Not steel walls or domes of glass, but a shimmering planetary shield stretching thousands of kilometres across space. A barrier against radiation, meteor strikes, and maybe even hostile visitors. Science fiction? Absolutely. But also, an idea that refuses to die. During the Cold War, the United States launched the Strategic Defense Initiative, nicknamed the Star Wars Project. Its goal? A space-based shield to intercept nuclear missiles before they hit. It never came to life, but the concept captured imaginations. A planetary umbrella protecting civilization from threats raining down from above. Now extend that concept. Picture satellites linked into a colossal lattice, powered by solar farms the size of Texas, creating a field of energy that bends radiation away. Imagine swarms of drones intercepting asteroids long before they come close. A literal suit of armour for Earth. Sounds insane? Maybe. But think about it. Life on other planets evolves defences as naturally as breathing. Spikes, toxins, camouflage. For us, technology is our biology. If aliens ever came knocking, or worse, crashing, this could be humanity's evolutionary shield. But the real hook isn't war, it's survival. Cosmic rays streaming from exploding stars, solar flares that could fry electronics, rogue rocks tumbling through the void. Earth has been lucky for billions of years, but luck always runs out. A shield could mean the difference between thriving as a spacefaring species and vanishing like the dinosaurs. The question is, would we build such a shield out of hope or fear? Would it be a tool of peace guarding humanity's cradle, or a weapon waiting to be abused? Science says the engineering is beyond us today, but imagination says, give us a few centuries, and the skies above Earth might shimmer with invisible armour. So when you picture aliens arriving, don't just ask what they look like. Ask, what will we look like to them when they see a planet wrapped in light? Far, the idea of a planetary shield sounds like something ripped from Star Wars, but here's the twist. Parts of it already exist. Not in the form of glowing domes or invisible force fields, but in small practical steps scientists are building right now. NASA, for instance, has tested the DART mission, literally slamming a spacecraft into an asteroid to see if we could nudge it off course. And it worked. A rock millions of tons heavy was shifted ever so slightly, proving that planetary defense is not just science fiction, it's engineering here and now. Other projects look to the skies in different ways. Researchers are studying sunshields, gigantic mirrors or clouds of dust positioned in space to deflect a fraction of the sun's light. Why? To cool Earth and counteract climate change. It's not exactly a force field, but in principle, it's the same idea, shaping the environment above Earth to protect life below. And let's not forget the humble magnetic field. Earth's invisible shield has guarded us for billions of years, deflecting solar wind and cosmic radiation. Some scientists wonder, if Mars ever becomes our second home, could we build an artificial magnetic shield to restore its lost atmosphere? If that day comes, humanity would have literally engineered its own planetary armour. So the science is creeping forward. Piece by piece, mirror by mirror, magnet by magnet, humanity is laying the groundwork for a future where planetary shields are not a metaphor but a fact.
Yes, a direct
The
hit.
real question is, how far will we go? Would we cover our skies in orbiting solar sails the size of continents? Would we build magnetic coils around an entire planet? Would we cage ourselves under our own protection? It's easy to laugh at the thought of Earth wrapped in glowing armour, but when you realise the first prototypes are already orbiting above your head, suddenly it's not so funny. It's inevitable. And if we can build shields to defend against rocks and radiation, maybe one day we'll have the courage to look outward, not with before, but with readiness. Because the universe doesn't hand out guarantees, it only asks, are you prepared? The universe rarely offers happy endings. You return to Nimbus, the world of endless clouds, but something has changed. The blue star Carulius, once a beacon of heat and light, is beginning to rage. Its fuel is burning faster, its core unstable. The countdown has started. Look around. The sky ocean of Nimbus teems with life. cloud plankton drifting in swarms, sky whales rising like pale giants, jet squids darting in quick bursts. For hundreds of millions of years, they've ruled the skies in fragile balance. But now, their entire world is on the edge of annihilation. The temperature spikes. Lightning crackles through the cloud seas, brighter and more violent than ever before. Updrafts twist into colossal storms, shredding parachutes of plankton, scattering billions of tiny lives like sparks in the wind. Far above, a sky whale opens its net for one last harvest. It filters the clouds, capturing plankton in radiant sheets, but exhaustion drags it down. Jet squids seize the moment, stabbing with needle beaks, siphoning the glowing nectar. For the whale, there will be no recovery. It drifts, collapsing, its vast balloon folding in on itself as it falls endlessly into the crushing depths. The star grows hotter still. Caerulea flares with ultraviolet fury, flooding Nimbus with radiation. Entire swaths of cloud life ignite in silent flashes. Plankton threads burn away like cobwebs touched by flame. Predators and prey alike vanish in blinding arcs of light. And then the sky itself begins to tear.
The cosmos
As
holds
Caerulea
untapped
nears its
potential
final
for
stage,
expansion
it pulses
and resource
violently.
acquisition.
The shockwaves ripple through Nimbus's atmosphere,
Oh my God!
ripping storms apart, unraveling the world's delicate balance. For the creatures of Nimbus, there is no escape. They cannot flee their home. They can only rise higher, drift lower, or collapse in place as their sky ocean unravels. You hover there, powerless, watching a civilization of clouds meet its doom. In just a few million years, a blink in cosmic time, everything here will be gone. It feels tragic, but maybe it's something else. Maybe it's miraculous that it existed at all. That evolution carved out beauty in vapor, created giants from gas, and let them live, even briefly, under the cruel glow of a dying star. Nimbus burns, Caerulea flares, and you are left with a haunting truth. In the cosmos, survival is never guaranteed. The silence after chaos is always the loudest. You leave Nimbus behind, carrying with you the image of giants falling and clouds unraveling. It's a reminder. Life in the universe is fragile, temporary, and often doomed by forces far beyond its control. Back on Earth, that truth should make us pause. For all our technology, for all our cities and satellites, we are just as vulnerable. A single asteroid, a single flare from the sun, could rewrite the story of humanity in an instant. And yet fragility can spark ambition. Where some see danger, others see opportunity. Imagine this. The same rocks that could wipe us out also carry unimaginable wealth. Gold, platinum, rare minerals, ingredients for spacecraft, electronics, even medicine. Out there in the asteroid belt lie fortunes greater than all of Earth's mines combined. This is
What
the
do
next
aliens
great
look
frontier, the space gold rush. Just as
What
America
will
once
we look
surged
like?
west in search of gold, humanity may soon surge outward, chasing treasure among the stars. Picture fleets of robotic miners clawing into asteroids the size of mountains, harvesting metals atom by atom. Already, companies are dreaming about it. NASA has targeted a metal-rich asteroid named 16 Psyche, a world worth, at least on paper, more than all of Earth's economy combined. It sounds like science fiction, but missions are being built, rockets tested, and prototypes drawn. The gold rush has not begun yet, but the stakes are set.
The choice
Of course,
is
there's a
yours.
darker side. What happens when resources that
path
once
will
fueled wars on
humanity
Earth
take?
become limitless in space? Would nations cooperate or compete? Would mining colonies be cities of prosperity or battlegrounds of greed? For now, it's only a dream. But one day, humanity might look up at the night sky not with wonder, but with dollar signs. And in doing so, we could spark the fastest era of exploration in history, not because of curiosity, but because of problem. So maybe, while aliens drift and die in far-off worlds, humans will be busy carving up the heavens for ourselves. And yet, there's still one surprise left. One twist that changes everything you've just seen. We've travelled through oceans of darkness, forests that sing without eyes, skies filled with living balloons, and magnetic moons where flowers float like kites. We've imagined shields around Earth and even a cosmic gold rush. But here's the twist. The real aliens we've been searching for might be us. Think about it. If humans spread into space, colonizing Mars, mining asteroids, sailing between stars, we will not remain the same species. Evolution won't stop at Earth's atmosphere. In low gravity, our bones may thin, our muscles may shrink. In different light, our eyes may shift. With new technology, we might merge with machines, redesigning ourselves to survive where biology alone would fail. To a visitor from the distant future, humanity might look as strange as the blind grazers of Ipa or the balloon whales of Nimbus. Our descendants could become the aliens in someone else's sky. That's the final unsettling truth. The question is not only, what do aliens look like? The real question is, what will we look like once we step beyond Earth? Will we be explorers, predators, protectors, or something so unrecognizable that Earthlings of today would not even call us human? The universe is vast, dangerous, and filled with mysteries, but the strangest life of all may be the life we are about to create ourselves. So now it's your turn. Do you think humanity will survive to become the aliens of tomorrow? Or are we just another fragile species waiting for extinction? Tell us in the comments. And if you've enjoyed this journey, hit like, subscribe, and share this with a friend who loves to wonder. Because the more of us who ask big questions, the closer we get to real answers. The portal closes. Earth comes back into view. Warm, familiar, alive. For now, this is home. But one day, who knows? Maybe someone, somewhere will be telling the story of us.